Hey there, hi there, ho there. Welcome back. This is Unit 5. We're talking about minerals and rocks. Excuse me. So we're just going to take this unit to cover pretty much all of minerals and rocks in a very quick fashion. If this kind of stuff does interest you, Geology 101 does get a little bit deeper into minerals and rocks. Spend a whole week just on minerals, a whole week just on the igneous rocks, a whole week just on sedimentary rocks, a whole week on metamorphic rocks, which are the three types of rocks you'll come to learn in a moment. But for this class, it's not absolutely necessary to understand the ins and outs of natural disasters and hazards. It can be helpful, so we will incorporate that a little bit, but we'll only spend this week really touching on, again, minerals and rocks. So, you know what? Why not? Before we get started, let me give you the first part of the super secret code. It is the number 1. You got me? The number 1. One more time. The number 1. So speaking of number 1, section 1. So let's talk about minerals. These are the building blocks of the earth. So a mineral, as defined, is naturally occurring, inorganic, meaning not alive, not from plants or animals, solid, crystalline substance with which has a fixed structure and chemical composition. Now, when I say crystalline, that doesn't mean they all look like crystals. Some do, but we're talking about at the atomic level, kind of how the atoms and molecules are all arranged. So a mineral, as defined, excludes man-made and organic substances. Organic substances, for instance, bones. Bones are created by a living organism, humans, dogs, whatever. So bones are not minerals. And anything man-made. So diamonds, for example, can be considered a mineral. However, there are also man-made diamonds. Those would not be considered a mineral because it is man-made. So, to just get a little grasp on minerals, we can't not talk about the periodic table. So, if you've ever dabbled a little bit in chemistry, took in a chemistry class, or here, or at high school, or whatever it may be, you may have heard of the periodic table. The reason I bring this up is because, just like every substance in the entire universe, minerals are composed of elements and compounds. Elements are the basic building blocks of everything around us. And here's a whole table of all of these different elements, from hydrogen to helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, iron, Au is gold, Ag is silver, whatever it may be. All right, everything in the universe is made of this stuff. All right, so elements are the basic building blocks of everything around us, including minerals. Elements can either be found in their pure form, so just kind of by themselves. So if you found a chunk of gold, it would just be a bunch of gold atoms. Or it might be for a combination of things. For instance, salt is the mineral halite, which is a combination, my goodness, of sodium, Na here, and chlorine, Cl. NaCl makes sodium chloride, which is salt. And the mineral name of salt, the scientific name of salt, is halite. So elements can come together to form compounds. Different compounds also make up things. So everything's made up of elements. Those elements can be on their own or in combination with other things known as compounds. I'm getting to the reason I'm talking about all this in a moment. In the Earth's crust, looking back at that periodic table of the well over 100 plus elements that are on the periodic table, in the Earth's crust, there's only really 12 big ones, including oxygen, which is 45% of the Earth's crust, oxygen atoms, not oxygen gas. Oxygen gas is when an oxygen atom and another oxygen atom get together, and the chemical formula of oxygen gas is O2. I'm just talking about oxygen atoms on their own. When combined with other things, they can make a solid. So we have oxygen, silicon, and these two things make up, 72.4% of the Earth's crust. So the vast majority of the Earth's crust is made up of oxygen and silicon. So if we're looking at minerals and or rocks, then we should see a lot of oxygen and silicon in minerals because this is what the crust is mostly made out of. We also have things like aluminum, iron, calcium, magnesium, sodium, potassium, titanium, and then even smaller hydrogen, manganese, phosphorus. And then everything else, all those 100 plus other elements, only make up 0.77% of the Earth's crust, the hard outer layer. So, let me just show you how the different elements combine to form compounds, which can create our different minerals. So this is the mineral garnet, considered a gemstone as well. Maybe it's your birthstone. I forget which month it is. But you can see it has 12 oxygen atoms and 3 silicon atoms, which there's a lot of those in the crust. Therefore, more likely than not, we're going to find a lot of that in minerals. Same thing with aluminum. I think aluminum was third on that list. Calcium, magnesium, and iron, also in that kind of big 12 abundant minerals in the crust. Olivine, another mineral. Silicon, oxygen, again, the big 2. Iron, magnesium, again, all of those were in the big 12. Both garnet and olivine we'll look at in lab. Don't hold me to that, I could be wrong. Muscovite, very interesting, flat, flaky mineral. Here's a lot of oxygens again, a lot of silicons. We have potassium, aluminum. Again, these are big things in the crust. Here's quartz. Quartz is made up of just silicon and oxygen, the 2 most common things in the crust. Therefore, quartz is actually the most common mineral in the Earth's crust. Quartz takes on many different forms, crystalline structure, large, this white blobby structure. A little dark here. It could be pink, it could be purple, it could be black, it could be clear, it could be white. But in all cases, the formula for quartz is SiO2. So since, again, silicon and oxygen make up the vast majority of the crust, quartz is going to be the most common mineral we find in the crust. Fun little mineral to find. Hematite, another mineral, contains Fe, which is iron, and oxygen. This is actually a mineral that we mine out to extract iron in order to make steel. Calcite, another mineral, calcium, oxygen. Now we have this carbon atom thrown in there. Okay, interesting stuff, Pyrite, also known as fool's gold, some iron, but then we have something else in there. Sulfur, that's what S stands for. Diamond, ooh, that's what a diamond looks like before it's cut and polished. That's a raw diamond, that's what they look like. And that chemical formula is just C for carbon. So what I'm getting at is that minerals are made of stuff, atoms. And all of these different atoms are these different elements on the periodic table. Sometimes it's just one single type of element that makes up a mineral. Sometimes it's a combination of 2. Sometimes it's a whole bunch. But in any case, it's the unique combination of these different elements and or compounds that gives us this wide range of minerals that we have on Earth, somewhere over 4,000 different minerals, but quartz being the most common. The reason, for instance, diamond is so rare, diamond's made of carbon. Carbon wasn't on that kind of big list of most common elements. It was part of that. All other elements only make up 0.77% of the Earth's crust, including carbon. So, there's not a lot of carbon, therefore there's not a lot of diamonds. Go figure. What else was I going to say about that? So, we'll talk about how we identify different minerals coming up here in the next section. But before I do, what the heck? Let's go ahead and give you another part of the super secret code. It is the number 5. You got me? The number 5. One more time, the number 5. So, we'll pause there. When I come back, we'll talk about how we can describe minerals, its characteristics, which will help us identify and differentiate all the different minerals, all 4,000 plus different minerals that exist on the Earth, at least that we know. See you back here in just a second.